All right, good afternoon, students. So, I have covered Marine Eco Lab 2, Part 1, and also Marine Eco Lab 2, Part 2 in your videos. All right. So, once you have seen and understood both the presentation and the videos, this is the part that you would have to actually use to submit your Lab 2 report. So if you go to eLearn, you will be able to find the videos as mentioned, and then the lab, the PowerPoints, and this is the one that you need to submit. So if you click here, this is what you will find. Okay, so this is the lab report that you need to send to me by, where have I written? 17th of March. So let's look into this a little bit detail, okay? So that you won't have any issues, or if you do have issues, please raise it up to me during our class session. But I want you to get a head start of what you would be expected to do. So as I mentioned, because biodiversity is covered into two parts, what is having to understand the concepts and then later applying the ecological indices. So you have already been grouped into 16 groups from the ones we've discussed in our lecture and also our lab. So please stick to this group. The list can be found on your e-learning. So remember how I mentioned that the data has to be retrieved from your field trip or your kerja lapangan data. So that data is now, I know you've grouped in different groups. Now, the 16 of you, you would actually have to replicate or use similar data, but it has to be on this various habitat or environment. So at least one or two groups will be working on rocky intertidal, sandy intertidal, coral reef, demersal zone, benthic zone, neritic zone, and only one of this data is applied throughout your lab report. In all of your discussions and answers, please provide in-text citations. So when you mean by in-text citations, of course you have your reference list. But in your in-text citation means that if you're quoting something, if you're reading something and you want to write a text like coral reef ecosystem are going to climate change, your in-text citation will be the author and the year. So it'll either be, say, Irfan 2020 or Darshini and Yazid 2020. If it's going to be more than three, it's going to be, say, Zul Hakim et al. 2020. That is what in-text citation is. And you're supposed to include that wherever possible and include the references as well at the end of the report. This is a must. If I don't see this, obviously marks will be deducted. Under the main topic of measuring biodiversity, you are allowed to use two different stations for comparisons for different sampling cohorts, if need be. Now, it really depends on how good the data that you actually have gotten for your batch. I've been noted by Irfan that he will also take in data from the seniors. So you should by then have, by right, you should have more than ample data to work on. So again, by right, replicates are never supposed to be treated as separate cohorts. But for the sake of this practice, we will treat them as cohorts. Please don't ever say that I have actually said, oh, replicates can be used as cohorts. No. I repeat, replicates are replicates so that you will have a standard error that gives you an average of the data that you're supposed to get. Only for the sake of this exercise are we considering this as cohorts, okay, as separate groups. Now, in all of your calculations, always provide the following: the table of your data, formula of which you are instructed to apply, and also a breakdown of the flow of your calculation. And when you're doing your reference list, please use APA style of referencing, okay? So instructions, so when you're filling this up, again, bearing in mind, if you're working on coral reefs or etc., just stick to that all the way through. So biodiversity or biological diversity is simply describes the number or variety of organisms with a particular area that has three components: species diversity, ecosystem, genetic diversity. It's often used as a measure of health or biological system. So 5 ways that biodiversity has influenced you or your community. Please bear in mind, with the environment you're working with. So if it's a group that is working on corals, how has biodiversity for corals helped with your community? If you're working on rocky shore, how has rocky shore biodiversity helped? If you're working for sandy shore, how has sandy shore biodiversity helped, both ecological and economical? Please don't mix up the rest. If you're using corals, go corals all the way through. I repeat, please be very focused on your habitat and your environment and use that all the way through. Okay, the next part of this work. Provide the data sheet of your sampling trip here in the following table. So you are free to provide more columns. This is just an idea of what's there. For extra details in your table, or use a separate page if the space below does not suffice, or if it's not efficient, it's not enough. For example, if you are trying to differentiate biota from two separate stations. So please verify your taxon names on reliable sites such as worms, okay? Again, worms is a site for verification of the names, the scientific name. It is not for species identification. It's two very different things. It means to say to verify, meaning is the name still applied or is it a different name now? That is what verification means. It's not to help identify. It's not a site that has pictures. There's some that have pictures, but it's not solely used for species identification. So please bear that in mind. So when you're working on this, again, these are different examples, but for your group, if your group is working on intertidal rocky shore, then you delete all of this. Don't leave this as it is, okay? If you're working on intertidal sandy shore, delete the rest. Again, then, when it talks about equipment, of course, if you're working on benthic zone, you might have used Smith-McIntyre at the time, or you might have used, I don't know, grab anything. Just make sure whatever it is, please be very thorough with what equipment you use for your environment. If at all you have a mesh size, meaning to say like if you were using plankton, was there a sieve size? Was there serial filtration? What was the date? If you had different dates, put in those different dates. What are different stations that you work with the coordinates, okay? And mind you, with the coordinates. Okay, I know some of you are unable to identify through genus or species, never mind. So work with the best that you can, but also put a picture here. A lot of you are going to tell me that you may not have taken pictures, so it doesn't matter, but I want you to take a picture if you have to from the website, but please cite it here. Please use the reference because it is not of your picture, so it has copyright infringement. So whatever pictures that you're taking from the internet, please put here. But you're also not allowed to simply take any random pictures. It has to be pictures of species that are found from Pulau Bidong. So if you're not sure what, you're going to have to read up some books or read up some literature and papers and find out what species are present in those areas. Okay. Provide a link for the site and date of your taxon verification here. All right. And then going on to this, species identification. So example, if your group is working on plankton, so you have varying different degrees of plankton. So you should be able to at least identify to either family, genus, or species. So I want you to take at least 5 different species. If you cannot identify species, doesn't matter, but it has to be 5 different kinds. And I want you to create your own dichotomous key. The dichotomous key, you can see some examples here. Biodichotomous key usually is regards to your morphology. So has eyes, without eyes. And then the next one leads to has legs, without legs, something like that. Okay? Then next, your habitat. So I want you to describe in 400 words about the type of habitat of your sampling choice in Pulau Bidong, be it biotic, abiotic, or interactions. Okay, you have to mention all of this. What are the biotic parts, the abiotic, and the interactions. Identify and explain the environment of that habitat. So write all this down, but then also put the keywords of the biotic factors here, the abiotic factors here, and what is the habitat that you're working on here. Then we come to the species niche part. An ecological niche is the role and position of a species it has in its environment. This includes all of the interactions with the biotic and abiotic factors. Competitive exclusion principle states that the two species can coexist if their natures are sufficiently different. Okay? So if you're working on plankton, or if you're working on, say, different starfishes, sea urchins or whatever, so then you keep that particular species in mind of your environment, or coral fish maybe. So in this section, what is the species that you would like to focus on? Again, what is the name of the species? Put it there. How does the species meet the needs for food and shelter? Write down, is there a particular survival strategy for the species? Again, a lot of these things were not covered in your field trip sampling, because yes, at the time it was just your technique of field sampling. But this is what marine ecology is about. I want you to not just forget about your field sampling trip. I want you to relate back to the work that you did before and look into those details. This is the part where you need to do homework. You probably saw that, you observed this, but certain things may not have made sense to you. Did you look into like this, the survival strategy of that species? So this is the part you need to do some homework. How does the species that you are relating to reproduce? Again, yeah, if you're talking about this one particular species of plankton, you need to stick to that all the way through, not just simply change species at your whims and fancy. And then also elaborate the biotic factor this species interacts with the environment, and also the biotic factor. And then from your data sheet of the other organisms, is there a likelihood that the species you mentioned competes with other species for the same resources? Is that particular phytoplankton competing with another species of phytoplankton? If it's for light, then there's ample light, so not a problem. Something like that. And then trophic position. So example, if you're working on corals, yes, maybe a lot of you would have collected coral fishes, okay? But on top of that, you had other groups that worked on plankton. So don't be afraid to overlap certain things, because this is what is found here. You're not supposed to treat it as different entities. You're supposed to relate back. Of course, this group has worked on plankton, so we have to look at the plankton data. And then the fact that you were looking at nutrients. So there were groups who were looking on nutrients, so you will have to look into nutrients. Those who were working on bacteria, those who were working on algae perhaps. So all of this, there are things that is going to be overlapping. It's okay, doesn't matter. But don't forget, you say if your group was working on open ocean planktons, then the focus is on planktons, but also looking at how everything else relates. So there's no way you're going to be overlapping other people's work. But again, this is for Pulau Bidong, so I want you to illustrate what would the trophic level be like, say, of the benthic zone in Bidong Island or nearby Bidong Island. Or how about for coral reefs or for rocky shore? So I want you to design based on your understanding, based on your literature, or what you're able to find. And then this is where part 2 comes in, measuring biodiversity. So I believe a lot of you are well equipped with a lot of information from Dr. Maiza's class for statistics. So I want you to be able to apply this here also. So knowing the species that you found, we're going to look into species richness, species evenness, and species heterogeneity. So I want you to be able to calculate the species here based on the proportion of species, species richness, Menhennick's and Margalef's index as well. Okay, so fill that up. Again, it looks separately based on species richness. And then this one looks into species heterogeneity. And then this one looks into species evenness and community similarity. And then the discussion will come into analyzing that values. What are the similarities and differences found between Menhennick's and Margalef's similarity? And what are the differences? And then list 2 other species methods and explain what are the purpose of this index. Okay, so when you're done with that, then comes into species diversity. What are the minimum and maximum ranges of the values for Simpson's index and Shannon-Wiener's index? And what does this value mean? So I want you to write what the value is and what does the value mean. If it's a 10, what does 10 mean? If it's a 1, what does it mean? If it's a 0, what does it mean? So the same thing also applies for Simpson's diversity index. And then explain the what differentiates Simpson's index diversity. There's a difference. So what are these differences? And then species evenness, There are different species abundant models. So which is the most applicable, or how would you differentiate above the 4 types of abundance, okay? And how is this applicable to your work? And then, of course, provide all of your references, again, according to APA style. This is the rubrics of your work. And then once you're done, please submit it on the 17th. And that's it. Thank you very much.